Welcome to Synapse Daily. Chapter 1, The Architect of Shadows. The year is 1964. If you were walking through the streets of Moscow, you would feel a strange paradox. On one hand, there is the gray, utilitarian reality of the Soviet Union, lines for bread, the hum of heavy industry, the watchful eye of the KGB. But on the other hand, there is an electric optimism. This was the era of the cosmic man. Yuri Gagarin had already circled the Earth, becoming a secular god of the socialist world. To the Soviet leadership, the moon wasn't just a celestial body, it was the next province of the USSR. While the American Apollo program was built on the back of public spectacle and democratic funding debates, the Soviet lunar program was a creature of the shadows. It lived in closed cities, towns that didn't appear on any map. It was here that a secret group of engineers, led by a man named Vladimir Barmin, finalized a document that should have changed the course of human history. They called it Project Zvezda. The Star. To understand the sheer scale of Zvezda, you have to understand Vladimir Barmin. In the hierarchy of Soviet space, names like Sergei Korolev, the chief designer, got the glory in the history books. But Barmin was the foundation. He was the head of GSKB Spetsnaz. His specialty wasn't rockets, it was the ground. He was the man who figured out how to keep a rocket from melting its launch pad. He was a master of logistics, steel, and concrete. When Korolev approached Barmin in the early 60s, he didn't just ask for a landing craft. He asked for a home. Korolev knew that the Americans were fast, but he wanted the Soviets to be permanent. He didn't want a touch-and-go mission. He wanted a lunar embassy. Barmin took this challenge with a chilling level of technical sobriety. He didn't look at the moon with the eyes of a poet. He looked at it as a hostile construction site. The moon has no atmosphere to block micrometeorites. It has no magnetic field to deflect solar radiation. The temperature swings are violent, from 120 degrees Celsius in the sun to minus 170 degrees Celsius in the shade. Barmin's finalized 1964 concept was a masterpiece of modular engineering. He didn't plan to build the base on the moon, he planned to manufacture it on Earth and ship it. Imagine 9 massive metal cylinders, each a masterpiece of 1960s metallurgy. These weren't just cans, they were sophisticated life support pods. Question 1. In an era before microchips and modern computing, how did Barmin's team calculate the structural integrity needed to withstand a decade of lunar tremors and solar flares? The answer lies in the slide rules and the sheer brute force of Soviet mathematics. Chapter 2, The DLB Zvezda, a city in 9 cylinders. Let's step inside the blueprint. Imagine the sea of rains, Mare Imbrium. The landscape is a monochrome desert of gray dust. Suddenly, 9 silver spears descend from the black sky on pillars of fire. This was the deployment sequence for DLB Zvezda, Длительная лунная база, long-term lunar base. Each of the 9 modules had a specific, vital function. This was not a one-size-fits-all design. The command module, the brain of the base. This is where the radio arrays would point toward Earth, a tiny blue marble 384,000 kilometers away. The laboratory modules, 2 units dedicated to geology and biology. The Soviets were obsessed with finding water ice and minerals. The power plant, a specialized module that would house the nuclear heart of the station. The living quarters, 3 modules designed for sleep, hygiene, and the psychological preservation of the crew. The medical and gym unit, the most critical module for long-term survival. Barmin knew that the greatest enemy wouldn't be the vacuum, it would be the human body. In 1/6 gravity, your heart doesn't have to pump as hard. Your blood volume decreases. Your bones begin to leak calcium into your bloodstream, turning your skeleton into brittle glass. The Soviet gym module was designed with treadmills that used bungee cords to pull the cosmonauts down, simulating Earth's weight. But there was a more immediate danger: radiation. The sun is a beautiful, deadly furnace. Without an atmosphere, a single solar flare could cook the crew inside their metal tubes. Barmin's solution was elegant and ancient: the trencher. He designed a specialized lunar bulldozer. Once the modules were landed and connected, This automated machine would scoop up the lunar soil, the regolith, and bury the entire base under a meter of dust. Imagine being one of the 9 cosmonauts. You aren't living in a gleaming silver tower. You are living in a buried pipe, deep beneath the gray dust, listening to the hum of the air scrubbers. It would be claustrophobic. It would be dark. It would be the ultimate test of the new Soviet man. Question 2. Could you maintain your sanity knowing that a single seal failing, a single microscopic crack in the metal, would result in your blood boiling in less than 10 seconds? Chapter 3. The Nuclear Heartbeat and the Lunar Train. To power a city in the dark, you need more than batteries. The lunar night lasts 14 Earth days. During this time, the temperature drops to a level that would turn steel into glass. Solar power was a fantasy in 1964 for this scale of operation. The Soviets turned to the Topaz nuclear reactor. This was a compact, thermionic converter. It didn't have moving parts like a traditional Earth-based reactor. It turned heat directly into electricity. The plan was to land the reactor several hundred meters away from the main living quarters to minimize radiation leakage and connect it via heavy-duty cables buried in the dust. This reactor was the heartbeat. If it stopped, the heaters stopped. If the heaters stopped, the crew would be dead within hours, frozen into statues in the lunar night. But the Soviets didn't just want to stay in their buried pipes. They wanted to explore. And for this, Barmin's team designed one of the most incredible vehicles ever conceived, the Protopopov Lunar Train. This wasn't a small rover like the ones the Apollo astronauts drove. This was a massive, pressurized laboratory on wheels. It had 4 to 6 giant, mesh wire wheels, each with its own electric motor. Inside, 2 or 3 cosmonauts could live without their spacesuits for up to 30 days. It had a crane, a drill for deep core sampling, and enough supplies to travel 1,000 kilometers across the lunar surface. Imagine this, a convoy of nuclear-powered trains crawling across the craters of the moon, their headlights cutting through a darkness that has existed for 4 billion years. The cosmonauts would be inside, drinking tea from tubes, looking out of thick quartz windows at a landscape no human eye was ever meant to see. This wasn't just exploration. It was a claim of ownership. Every kilometer the lunar train traveled was a kilometer of Soviet territory. Question 3. Why did the Soviet Union invest so much into the long-term base while the Americans were purely focused on a sprint to the surface? The answer lies in the Soviet philosophy of cosmism, the belief that Earth is only the cradle of humanity, but one cannot live in a cradle forever. Chapter 4. The N-1 rocket, the Titan that refused to fly. If Zvezda was the brain of the Soviet lunar dream, the N-1 rocket was its spine. To transport 9 massive modules, nuclear reactors, and pressurized lunar trains to the moon, you need more than a rocket. You need a monster. The N-1 was the Soviet response to America's Saturn V, but it was designed with a fundamentally different and far more dangerous philosophy. Standing over 100 meters tall, the N-1 was a silver-gray pyramid of raw power. While the Saturn V used 5 massive F-1 engines, the Soviet engineers, led by Sergei Korolev, faced a crisis. They didn't have the manufacturing capability to build engines that large. Their solution? Complexity. The first stage of the N-1 was packed with 30 Nk-15 engines. 30 separate combustion chambers, 30 sets of fuel lines, 30 potential points of failure. Barmin's Zvezda base was entirely dependent on this machine. Each launch of the N-1 was meant to carry 1 block of the lunar city. But the physics of the N-1 were haunted. The plumbing required to synchronize 30 engines created a nightmare of vibration known as pogo oscillation. Between 1969 and 1972, the Soviet Union attempted 4 launches of the N-1. Every single one ended in a fireball. The second launch was the most catastrophic. It was the largest non-nuclear explosion in human history. The rocket collapsed back onto the launch pad at Baikonur, vaporizing the steel structure and shattering windows for miles. With every explosion of an N-1, a piece of Project Zvezda died. The modules were built and sitting in warehouses, the nuclear reactors were tested and ready, but the bridge to the stars had collapsed. Question 4. If the Soviets had opted for a smaller, modular assembly in Earth's orbit instead of a single giant rocket, would Zvezda be an active museum on the Moon today? Chapter 5. The Secret 9, Candidates for Exile. Who were the men chosen to occupy these buried tubes? The selection process for the Zvezda crew was even more rigorous than the selection for Yuri Gagarin's flight. They weren't just looking for pilots, they were looking for lunar monks. The crew was to consist of 9 specialists, a commander, a doctor, a biologist, 2 engineers, and 4 geological researchers. These men underwent psychological testing designed to break them. They were placed in pseudocamera, isolation chambers, 4 weeks in total silence. They were fed concentrated pastes and monitored for every twitch of an eyelid. The Soviet psychologists were terrified of lunar psychosis. On Earth, you can go outside. You can see green trees. On the Moon, for a year, your entire world is 4.5 meters wide. You are constantly breathing recycled air that tastes like metallic ozone. You are drinking water that was, just hours ago, your own sweat and urine. The mission was a one-way ticket for at least a year. There was no rescue craft waiting in orbit. If an illness occurred, the doctor on board would have to perform surgery in 1/60h gravity, with blood floating in the air like red pearls. They were trained to be a self-sustaining tribe, loyal to the mission above even their own survival. Chapter 6, The Lunar Economy, Helium-3 and the Red Future. Why spend billions of rubles on a base in the Sea of Rains? The Kremlin wasn't just interested in science, they were interested in the future of energy. Even in 1964, Soviet physicists were theorizing about helium-3. The Moon's surface has been bombarded by solar winds for billions of years, depositing helium-3 in the regolith. On Earth, this isotope is incredibly rare. On the Moon, it is a potential fuel for clean nuclear fusion. The Zvezda base was meant to be the first mining camp. The long-term plan included massive solar furnaces that would bake the lunar dust to extract gases. They envisioned a future where the USSR didn't just control the oil of the Caspian Sea, but the energy of the solar system. Zvezda was the staking of the claim. The Lunar Train wasn't just for sightseeing, it was equipped with sensors to map the highest concentrations of minerals. They also looked at the Moon as a military high ground. From the Moon, you can observe every square inch of Earth as it rotates. It is the ultimate high fort. While the Outer Space Treaty of 1967 eventually banned weapons of mass destruction in space, the 1964 blueprints for Zvezda still had defense observation sections that were heavily redacted. Chapter 7, The Silence of 1974. By 1974, the race was over. The Americans had walked on the Moon 6 times. The Soviet Union was facing an economic slowdown. The N1 project was officially scrapped, and with it, the funding for Project Zvezda vanished. But the most tragic part isn't that it was cancelled, it's that it was forgotten. The Kremlin ordered the destruction of several prototypes. The blueprints were moved to archives that required special access. Vladimir Barmin, the man who built the dream, moved on to other projects, but colleagues said he kept a model of a Zvezda module on his desk until the day he died. The Soviet Union didn't want the world to know how close they came. They didn't want to admit that they had a fully finalized plan for a lunar city while the Americans only had a plan for a tent. Chapter 8, The Modern Echo, Why Zvezda Matters Now. As we sit here today, looking at the Artemis program, China's ALRS, International Lunar Research Station, and SpaceX's Starship, we are seeing the ghosts of Zvezda. Modern engineers are returning to Barmin's original ideas. Regolith shielding, we now know Barmin was right, burying habitats is the only way to survive long-term radiation. Modular expansion, the Lego-style assembly is now the standard for the ISS and future lunar gateways. Nuclear power, NASA's fission surface power project is almost a direct descendant of the Soviet Topaz reactor. Project Zvezda was a masterpiece of 20th-century ambition. It was a vision of humanity as a species that doesn't just visit other worlds but inhabits them. It was the moment we almost became a two-planet civilization. The Sea of Rains remains empty for now. The dust sits undisturbed. But if you look at the blueprints from 1964, you can almost hear the hum of the fans and the clatter of the Lunar Train. The star never rose, but it lit the path for everyone who followed. Question 5. We have the technology now. We have the rockets. We have the maps. The only thing missing is the audacity of 1964. Are we waiting for another Cold War to find our way back to the moon, or will we go this time as a united species? Like this video if you learned something new. Comment your thoughts below and subscribe for more fascinating stories.